So let's do some examples using the quotient rule. Now remember that if I have two differentiable functions divided by each other, the derivative of that fraction is low d high minus high d low over low. Right? That's the mnemonic device that we talked about in the last video. So to do that, in this case, we're going to find the derivative at a specific point. So we want to find the derivative of sine of x over x. So to do that, we've got to do low d high minus high d low over low. So knowing that, we know that the derivative of the sine function is cosine, and we know that the derivative of x is 1. So then we need to evaluate this at pi over 4. So what we know is that cosine of pi over 4 is the same thing as sine of pi over 4, and that's the 1 over the square root of 2. So that's pi over 4 times 1 over square root of 2 minus 1 over square root of 2 all over pi over 4 squared. And you can simplify that. That's perfectly fine. You could plug that into a calculator. But for our purposes, that's going to be an acceptable answer. Now, for something like this, cosine of t over t to the 5th, we're going to take a very similar approach to what we have here. We're going to say that the derivative with respect to t, cosine t over t to the 5th is low d high minus high d low over low. Now, in this case, we have t to the 5th squared. So, by the power of exponents, remember, if you have something in number 2 a power, and then that is also raised to a power, you actually multiply the powers. So, over here, we're going to have t to the 5th times negative sine of t minus cosine of t times 5t to the 4th all over t to the 10th. Now what I notice is that I can factor a t to the 4th out of this and a t to the 4th out of that and a negative 1 that I can pull out front. So I'm going to pull that out front, and I'm going to have sine of t plus cosine of t all over t to the 6th. And that's how I would do that one. Now for this particular one, this is actually probably easier than this one. It's just got more terms in it. So to find that derivative, I go low d high minus high d low all over low. So we have a lot of terms here, but what we're going to find is the derivatives they collapse polynomials pretty easily. So I end up with x squared minus 6 times 0 minus 3 minus 2x minus 2. So this term stays the same. Derivative here is 2x. Derivative of negative 6 is 0. All over x squared minus 6 squared. Now, you may want to simplify this completely, and that would be fine. So let's try. I don't know how well it'll simplify. I get a negative 2x cubed here, and I get a positive 2x cubed here. So I know those are going to cancel. And I get a negative 3x squared here, and I get a positive 6x squared. So that's going to leave me with 3x squared. And I get a positive 12x, and I get a negative 8x. So that's going to leave me with positive 4x. And I get positive 18. And I don't get any of that over here because there's no way to get that. So that leaves that over x squared minus 6 squared. So there's really no way to simplify that other than this is about as simple as you can get. You can pull an x out front. I don't know what that would do for you. But ultimately, this is the quotient rule. You take the top, you take the bottom, you do that. Now I'm going to make one more thing here that we haven't talked about, but this is a good example while you're watching. Is if I wanted to take the derivative of x squared secant x, that looks like a product rule. And you'd kind of be right, but it might be easier to think about secant in terms of cosine. Remember, secant of x is 1 over cosine x. So it might be easier to think about that in terms of x squared over cosine of x. Because the derivative of secant is like secant tangent, and it can get a little messy, whereas we understand cosine pretty easily. It's got that derivative of negative sine, so it's not a problem. So rewriting things with secant in terms of cosine and writing things in cosecant in terms of sine, a lot of times will help you out. And even if you had something like you wanted the derivative of t to the 5th over cosecant t, sorry, derivative with respect to t, that's going to be easier as a product rule. So do yourself a favor and write those in terms of functions that are easier to deal with, and then worry about the differentiation method.